Let's spend some time looking at Harvester, which is SUSE's open source HCI solution. Harvester is open source, hyper-converged infrastructure software that virtualizes the entire stack, including the compute layer, the storage, and the network. To accomplish this, Harvester is built on top of multiple cloud-native technologies, and it combines them all together into one single product that provides a great user experience. For example, it uses Kubernetes at its core to provide a mature and stable orchestration layer. It also includes KVM as the virtualization platform, and it uses Kubevirt to take care of the virtualization management layer that orchestrates the running of virtual machines inside of pods. It also uses Longhorn to provide the persistent storage layer, and finally it uses Multis, which is a meta CNI to allow for multiple software-defined networks. Now, Harvester has been designed to work on bare metal, which provides users with a single unified API to deploy virtual machines and applications. Either a PXE boot or an ISO image can be used to install Harvester on bare metal nodes. Now, spinning up one or more nodes together creates a cluster, which can spin up virtual machines and even Kubernetes clusters on top of virtual machines. In essence, Harvester makes Kubernetes ubiquitous because it bridges the gap between the traditional HCI software and the modern cloud-native ecosystem. So at the architectural level, Harvester is a cluster of nodes, each one of which is running SUSE Linux, which, as you know, is a very stable and secure operating system, with Longhorn and Kubevirt providing the storage and virtualization layers. Now, the virtual machines spin up on top of this, and by default, each virtual machine connects into the management network, which in fact is a Kubernetes overlay network, which can access any virtual machine in the cluster. Multiple VLANs can also be created. The virtual machine can connect to multiple networks at the same time, providing the ability to isolate the traffic across virtual machines. Now, this networking is provided by Multis, as well as Harvester's Network CNI plugin, which allows a virtual machine to be connected to multiple network interfaces, which is very common within the virtual machine world. Now, Harvester clusters multiple hosts together to provide a shared compute platform across all of them. This is cool because it allows administrators to manage all of these servers as if they were one single pool of resources that can be allocated to virtual machines and eventually, if running Kubernetes, to be allocated to containers as well. And as more nodes get added to the cluster, Harvester reconfigures itself just like any other Kubernetes cluster. Now, virtual machines can run any x86 operating system, including Linux or Windows, and users can start running virtual machines or spinning up Kubernetes clusters on top of those virtual machines. Now, Harvester uses an appliance-based model with an ISO that includes the operating system along with everything else needed to run a Harvester node. Now, Harvester boots up into a specific node, and as that node joins the Harvester management system, it can be administered through the Harvester management console. When used by itself, Harvester provides enterprise teams with an easy-to-use management console that consolidates their day-to-day operations for their virtual machine environments. When combined with SUSE Rancher, Harvester provides operators with a unified platform for both virtual machine workloads and container workloads, and as such, it's able to bring traditional IT apps into the cloud-native world as part of the IT modernization journey. The deep integration of SUSE Rancher and Harvester provides a unified pane of glass for both types of workloads. It also provides turnkey pathways to get Kubernetes up and running on HCI. It's now easier to take that bare metal in the data center and, with SUSE Rancher working with Harvester, orchestrate Kubernetes faster than ever before. In addition, SUSE Rancher can import Harvester clusters and utilize the SUSE Rancher authentication system for full RBAC control. The GitOps and cloud-native tooling in SUSE Rancher can now manage the entirety of the infrastructure, driving policy and pushing consistent updates across hundreds or thousands of HCI and Kubernetes clusters. And the cloud-native lineage of Harvester also makes it lightweight enough to be used across resource-constrained environments at the edge. Now, even though Kubernetes is at the core of Harvester, The Harvester operator does not actually need a deep understanding of Kubernetes, and this is because Harvester is designed from the ground up to use a friendly interface designed specifically for VM operators. For example, it uses concepts such as VMs, VLANs, and disk volumes. As such, the Harvester interface offers users an easy-to-use and familiar experience for anyone who's familiar with managing VMs. In summary, Harvester combines multiple open-source cloud-native technologies to provide a turnkey, fully featured out-of-the-box virtualization, storage, and networking platform that allows you to run and operate VMs as a cluster on bare metal. Harvester brings together the traditional HCI software and the modern cloud-native ecosystem. So, get started with it at harvesterhci.io.